Okay, today we are going to be looking at systems of inequalities. So they have inequality symbols in them instead of equal signs in them. Um, some steps that you need to kind of be familiar with, and I know you have learned this before, but just to remind you, when you have greater than or less than symbols and they're not underlined, that means when you draw the sign, you do them with a dashed line. If they're underlined, you do them with a solid line. And then you're going to, of course, determine which side of the region to shade on, and you can pick a point if you want, or you can kind of use your logic and figure that out, okay? And I will do some examples, so hopefully that will help you. Okay, so the first thing I'm asking you to do is to draw the graph of this inequality right here. You can see that it has x and y in it. Neither one of them are squared. So hopefully you are beginning to recognize that this is a linear inequality. We're also going to be looking at some parabolas and some circles today, but this one happens to be linear, okay? So you can graph this a couple of different ways. You can either find the intercepts, the x and the y intercepts, graph them and connect to the line if you would like, or you can get them into y equals mx plus b form, which is basically probably what most of you are going to do. So if I want to get this into y equals mx plus b form, I would add the 6x to the other side, and then I will have 3y is greater than or equal to 6x plus 9. I want to remind you that when you multiply or divide by a negative when you're dealing with inequalities, you do have to switch the direction of the sign. I have not multiplied or divided by a negative, so I don't need to do anything here, but if I had, I would. Okay, divide both sides by 3, and then they get y is greater than or equal to 2x plus 3. Okay, of course, you know that that means that's the slope and the y-intercept. So my y-intercept is at 3, so I'm going to make a dot there. My slope is 2 over 1. Remember, slope is rise over run, so that's your up, down over your left, right. My rise is 2, my run is 1. It's a positive slope, so it is going to look like this, up to right 1 or down to left 1. Okay. Because my inequality symbol is underlined, I am going to connect that with a solid line. Okay, so I'm going to connect those dots with a solid line. Basically what that means, oops, I didn't draw that very straight. Actually, I didn't have that point in the or that dot in the right spot, sorry. What that means is that your boundary is included in this. So my boundary is included, okay? And I need to find what this is telling me to do. I'm going to show you a couple different ways to do this. One way is to actually plug in points. So I'm going to pick a point on either side of that line. The easiest point to pick probably is 0, 0. If I plug 0, 0 in, okay, that means that my x is 0 and my y is 0. So I'm plugging 0 in for x and 0 in for y. So what that happens is this. If I plug 0 in for y, I get 0 is greater than or equal to 2 times 0, which is 0, because I plugged in 0 for x, plus 3. Is 0 greater than or equal to 3? No, it's not. That is not a true statement. So I am not going to shade on the side of the line of the point I picked, okay? I will shade on the other side of the line. Easier than that, you can kind of use logic. This is asking me to shade. This is basically, this is how I read this. Shade all y values that are bigger than, because it's a greater than symbol, this line, okay? Think about where y values are that are bigger than the y values on the line. They have to be above the line, okay? Y values that are bigger than the ones on the line are going to be above it. So I am going to shade that direction. Anything that is inside that shaded region or on a line in this case is part of the solution set, okay? If it was a dotted line instead, it would only be what's above the line, not what's on the line, okay? So in this case, it's asking me to, it says state the boundary of the region. So basically, I just need you to think about something like this. The graph consists of all points on or above the line y equals 2x plus 3, okay? Equals is the exact line, and then I'm also shading above it, okay? So I need to know that it can be on the line or above it in this case. If it was dotted, it would only be above it. All right, now we're going to look at two systems, and these are a little bit trickier because they are not necessarily graphs that you are super familiar making. Okay, you've done it. It's been a while though, so we need to kind of review it. All right, this first one, x squared plus y squared is less than 16. Hopefully you can recognize that as a circle. Okay, if you remember, circles give you your center point. In this case, my center point is at 0, 0 because I have nothing added onto my x and nothing added onto my y. So my center is at 0, 0. Remember that what's over here is your radius squared. So my radius squared is 16, which means my radius itself is 4. Okay, we're going to graph this. Basically, what that equation is telling me is that it's a circle. Okay, it's centered at 0, 0, and it has a radius of 4. Okay, centered at 0, 0, so here's my center, and it has a radius of 4. So I'm going to go 4 up, I'm going to go 4 to the right, 4 to the left, and 4 down, and I'm going to connect that circle. I know that it does not look real circular here because it's on the smartboard and it's gotten distorted because it's going from different size screens. So I apologize that it's going to look not so circular, but it is, okay? So you're going to connect this dot or the dots in this case for the circle with a dotted line. And the reason you're doing dotted is because that inequality symbol is not underlined, okay? So I'm going to connect it. This is not real circular, sorry, but I do need to connect it with a dotted line. Okay, then you need to think about where you're going to shade. Think about this logically. Okay, what this is saying is I want to shade all the values of the circle that are less than 16. Okay, all the values of the circle whose radius is less than the square root of 16, basically. Okay, if it's less than, you want to shade inside the circle. I'm just going to kind of do this right now to remind myself that I'm shading inside the circle. Okay, then I'm going to go over to the other equation, which is this one right here. This one has only the x that's being squared. So hopefully you can recognize that as a parabola. If you can't, use your 12 basic function sheet that I gave you at the beginning of your notes packet, and that should help you, okay? What this means is that it's a parabola, and because it's a negative right here, it opens down. This is going to tell you where the vertex of the parabola is. The vertex of the parabola is at 2 up. Okay, if you are really struggling with how to graph these, one thing you can do, of course, is to go to your graphing calculator. I can go to y equals, and I can just put that equation in. So in this case, it's negative x squared, and then plus 2. Okay, I can go ahead and graph it. There we go. So I can see what it looks like on my plot. I can also go to my table if I want, and I can get some coordinates to plot if you're not sure how to plot those. Okay, so you can scroll that up and down and use your calculator as a resource if you need to, if you're not familiar with these graphs. Okay, so I'm going to just erase this just so that it doesn't come out to be such a mess. But I will need to remember that I was shading inside the circle. And actually what I'm going to do, I think, is I'll shade it with blue so that I can have it be the same color. All right, back to my parabola, which is this equation right here. So what I know is that it starts at 1, or starts at 2, I mean, for its vertex, and it opens down. And again, you can go to your table if you want, and you can get some points to plot. No problem. go to your table and get the points to plot if you want. Otherwise, I kind of know enough that I can do this, okay? When I connect these dots, I also am going to connect them with a dotted line because that parabola is, or that inequality symbol is not underlined. So that means I'm going to connect them with a dotted line. And I have this parabola that looks something like this, okay? Then it's asking me to shade all the y values that are bigger than the ones on the parabola. All the y values that are bigger than the ones on the parabola. That basically would be anything outside the parabola is where I would shade. Okay? Your solution to the system actually is where these two graphs overlap. Okay? So I honestly don't care if you shade anything except for where they overlap. If you're going to shade it, then you need to be super duper conscious that you tell me really, really darkly where they overlap. And in this case, they overlap in this region in here. And I would love it actually if you would get rid of all other shading. That's really hard to do on the smartboard, so I'm not going to get rid of all other shading. My solution to that problem that I have here is to just very, very darkly shade in where they overlap so I have no question that you know where they overlap, and that would be the solution to the system. Okay? I need you to know that in this case, your boundaries are not included, and the reason your boundaries are not included in this case is because your lines are dotted, and so that discludes them, is that a word, from our solution set. Okay, so anything on the dotted line is not going to work. Okay, and oops, I guess that's it. I think I have one more for you though. So hang tight. Okay, hang on just a minute. I have to hit pause for a second. Okay, Ellen. This is the next problem that should be in your notes, but I'm actually going to wait and do that on the next video. Okay? So that is going to be it for this one. You are still going to get worksheet 74A for your homework, and you know everything you need to do on that worksheet. And this problem we will do on the next day's video. Okay?